A blessed day to everyone. My name is Chris, and I'm going to present to you a video tutorial on how to compute descriptive statistics in Excel from a group frequency distribution or step distribution. Descriptive statistics present numerical values that summarize a big set of data about its central values, spread, shape, and other location measures. In order to compute the descriptive statistics, a group frequency distribution or step distribution needs to be encoded properly in Excel to be able to use the data title or label, and the column titles. In this video, descriptive statistics will be computed using my previously designed Excel template. No manual computation will be made for all the descriptive statistics since the Excel template does them all. Let me introduce my Excel template. The Excel template has cells colored blue from which the data given and other given values are encoded from lower limits to upper limits and the frequencies of each interval. And also there are other blue cells that needs to be encoded with values. Example, in this set of cells, one needs to specify the percentile rank to be computed and then other required values from the group frequency distribution. Another set of cells require the encoding of the percentile point or percentile value in order to find for its percentile rank from the given data in group frequency distribution. Another set of cells also computes for the mode from the group frequency distribution. And there are instructions here what to encode. Example, in cell A6, we are instructed to encode the table title in cell B6. Then in cell B7, the category title will be encoded. In cell B8, it's the lower limit or lower boundary of the first class or interval to be encoded. In cell C8, it's the upper limit or upper boundary of the first class or interval to be encoded. And the rest of the lower limits will be encoded in column B following the lower limit or lower boundary of the first class, and the other upper limits will be encoded below the upper limit or upper boundary of the first class or interval. Then the frequencies will be encoded in column E. So, let's proceed computing the descriptive statistics by the use of the Excel template. Let us use the data on the age of respondents. Here is the data on the age of respondents with the given group frequency distribution. In order to copy or encode the values in the template, let's proceed back to that template. And since table title be encoded in B6, click at B6 and encode the title age of respondents. The next is to encode the column or the category title age in years. It is in B7, age in years. The next to be encoded are the lower limits. The lower limits start from 18 toward 74. They differ only by 7. Encode or lower limits starting from 18 towards 74, differing only by 7. The next step is to encode the upper limits starting from 24 towards 80 that differ only by 7. After encoding the lower and upper limits or lower and upper boundaries, encode their respective frequencies. So the frequencies 18, 20, 19, 15. Followed by the frequencies 98731. After encoding all the intervals and their corresponding frequencies, notice that the values appear in the formulas in column I. Example, the total frequency is 100 because there are 100 different ages. The class size is 7 because the lower limit of one class differs by 7 from the lower limit of the next class. The mean, its mean is 38.5. The mean of the group frequency distribution, the age of the group frequency distribution is 38.5. The sample standard deviation is here computed. The sample variance, which is the square of the sample standard deviation, is computed. The population standard deviation is computed. Notice that the population standard deviation differs slightly from the sample standard deviation. The population variance, the coefficient of variation from sample is also computed. The coefficient of variation from population is also computed. So when the data age in years is considered as a sample, then the appropriate coefficient of variation is coefficient of variation from sample. But when the data age in years is really the population, then the appropriate coefficient of variation is that from the population. The next is to find or to compute some other location measures like the percentiles. You know, there are percentiles, quartiles, and deciles as measures of location. Now, if a percentile is to be computed, one must specify the percentile to be computed. Quartile 1 is equivalent to percentile 25, quartile 3 is equivalent to percentile 75, median is equivalent to quartile 2, which is also percentile 50. So far, we have not computed the median yet. So, to compute for the median, let us have the percentile rank. Let us encode the percentile rank, which is percentile 50, to determine the median. So, if it's 50, the cutoff cumulative frequency or the cumulative frequency that we are to find from the cumulative frequency column is 50. So where is the 50th value from the lowest cumulative frequency value located in what interval? So in this case, 18, 38, 57. So it is located in the interval 32 to 38, the median class, because the cutoff cumulative frequency determines the median class. So the median class is 32 to 38 because it is in this class that the 50th value from the lowest is located. Hence, you can encode specific values being asked here to compute for the median. The first is encode the lower boundary of the percentile class, X class, which means in this case, the median class. So, since the median class is 32 to 38, its lower boundary is 31.5 because we subtract zero point 0.5 from the lower limit. Then, next is encode the cumulative frequency of the interval preceding the percentile X class or the median class. We know that the median class is 32 to 38 and its cumulative frequency value is 57. The cumulative frequency of the interval preceding it is 38. So encode 38. The next is the frequency of the median class. So since the median class is 32 to 38, its frequency is 19 in code 19. Hence, after encoding all of the values, we are given with the value 35.92 as the median of the group frequency distribution or median age of the group frequency distribution. Because we find for the median, which is percentile 50, and the lower boundary of the median class is 31.5, since the median class is 32 to 38. The cumulative frequency of the interval preceding the median class, since the median class is 32 to 38, its cumulative frequency value is 57. The preceding cumulative frequency value is 38. And then the frequency of the median class 32 to 38 has the frequency of 19, encode 19, and after encoding 19, the computed median age of the given group frequency distribution is 35.92 years old. If you want to find for other percentiles aside from percentile 50, for example, what about quartile 1? Quartile 1 is not computed yet, or the percentile 25. So, to compute for quartile 1 or percentile 25, let us delete the values of the blue cells here in this area. Okay? So, encode percentile 25 for quartile 1. 25 to be included. The cutoff cumulative frequency then is also 25 since there are 100 values in this data set. So find under the cumulative frequency column where the 25th value from below is located. And after finding 18, then 38. 38 just exceeds 25. So this is where the quartile 1 class or the 25th value is located. Therefore, the quartile 1 class is 25 to 31. 25 to 31 is the quartile 1 class. Remember, that's the quartile 1 class. So, to encode the lower boundary of the quartile 1 or percentile 25 class, since the percentile 25 or the quartile 1 class is 25 to 31, its lower boundary is 24.5. Since zero point 0.5 is subtracted from the lower limit of the percentile 25. So 25 minus 0.5 is 24.5. Next is to encode the cumulative frequency of the interval preceding the quartile 1 class or the percentile 25 class. The percentile 25 class or quartile 1 class is 25 to 31. Its cumulative frequency entry is 38. The cumulative frequency of the preceding interval is 18. So encode 18. After encoding 18, we are asked to encode the frequency of the percentile 25 class or the quartile 1 class. Since the quartile 1 class or percentile 25 class is 25 to 31, each frequency is 20, encode 20. After encoding 20, we are shown with the value 26.95, which is the value of the percentile 25. 26.95 is the percentile 25 value. Okay, so that is computing the percentile value from a given percentile rank. What if we are having the opposite? The opposite is we are given the percentile value and to determine the percentile rank, its percentile rank. So let's try to uh, find for a value from a given data here, any value. For example, let's try to have 40. 40, 39 to 45, 40 is in here, included in here. So what if we try to determine the percentile rank of 40? So encode the percentile value 40. Next is in what interval is 40 located? 40 is inside 39 to 45 interval. Since 39 to 45 is the interval where 40 is located, in code its lower boundary, it's 38.5 because 39 is subtracted by zero point 0.5. Then, the next is to encode the cumulative frequency of the interval preceding that class. So, since 39 to 45 is where 40 is located, its cumulative frequency value is 72. But the cumulative frequency value of the immediately preceding interval is 57, encode 57. And the last one, encode the frequency of the interval where 40 is located. So encode the frequency of 39 to 45, we have 15. Encode 15, and we are given with 60.241 or approximately 60. It means that 40 40 is having the percentile rank of 60, or 40 is the value or age that surpasses 60% of the ages. So that is the interpretation of percentile rank and its percentile value. The last to be computed is the mode. What is the mode of this data? The group frequency distribution. What's the mode? To compute for the mode, locate the interval that has the highest frequency. What interval here, what class here has the highest frequency? By the way, the highest frequency here is 20. And the interval that has the highest frequency is 25 to 31. 25 to 31. So, since we compute for the mode, encode the lower boundary of the modal class. The modal class or modal interval is 25 to 31. Its lower boundary is 24.5. Since 25 is subtracted by zero point 0.5. The next to be computed is the frequency of the interval preceding the modal class. The frequency of the interval preceding the modal class. Since the modal class has the frequency of 20, the frequency of the interval preceding it is 18. So encode 18. Next is to encode the frequency of the modal class, which is 20, and the frequency of the interval following the modal class. The interval that follows the modal class is 32 to 38, and its frequency is 19, in code 19. And we are given with the value 29.17 approximately in hundreds place, which is the mode. It belongs inside, or it is inside the interval 25 to 31, 29.17. That is how to compute for the mode. So that is how descriptive statistics are computed in the previously designed Excel template. Have a good day, everyone. God bless you. To God be the highest glory.